Hello, and welcome to our interactive campfire session titled Siemens Helping ARM Customers Engineer a Smarter Future Faster. Please note this session is being recorded. I'm Mike Santorini. I'm the EDA Content Director for Siemens Digital Industry Software. In this 25-minute session with experts across Siemens EDA and Siemens Digital Industry Software, I'll ask each panelist to introduce themselves and answer a kickoff question. Then we'll open it up to you to ask our panelists some questions, and you can ask your questions by submitting them in the box on the bottom of the page you're viewing right now. Being we have a short 25 minutes, let's get to it. As a bit of background for attendees, we have partnered with ARM ever since ARM was founded in November of 1990, and maybe even before that. When we were Mentor Graphics, I'm sure we worked with Acorn even before that. As Mentor Graphics, we offered a portfolio that uniquely suited ARM's IP developers, so the ARM itself, ARM's hardware design customers, and also their embedded software customers. And as you may or may not know, Mentor was acquired by Siemens in 2016. And now as a part of Siemens Digital Industry Software, we have an even more comprehensive portfolio of EDA and embedded software solutions for ARM and its customers. But in addition to that, as a part of Siemens Digital Industry Software, we also now offer technologies that break down the barriers between design disciplines and that break down the barriers even between design, manufacturing, and enterprises. So companies can reach new levels of innovation more broadly across their entire business ecosystem. So to kick things off, I'd like to ask each panelist to first introduce themselves and the technology area they represent. Then I would like them to briefly describe how their technology is currently helping ARM customers innovate. And then I'd like them to hit at what's in the future now that we have a portfolio that crosses engineering domains. I'd also like, before we even kick it off, I'd also like to note that Aileen Ryan was planning on joining us from the UK to tell us about Tessin and especially the exciting new area of embedded analytics, but she can't be with us today. Something came up at the very last minute. So we're going to Mark Olin to kick things off. Mark?
Thanks, Mike. Hi, everyone.
Yep.
My name is Mark Olin. I'm the Product Management Director at our Design Verification Technologies division, or what we call DVT. At DVT, we're working closely with Jean-Marie's Hardware Assisted Verification division. He'll be up next to provide ARM licensees a complete platform of verification engines, including, in our case, simulation, which happens to be performance tuned for ARM IP, and formal verification technology that utilizes reinforcement machine learning technology to achieve unmatched solving performance. In fact, our Questa simulator is currently running in the cloud on both x86 as well as ARM architectures, and ARM is indeed one of several companies running Questa simulation in the cloud. We also provide common debug and coverage solutions for both the Questa and Veloce platforms, and are in the process of rolling out a brand new common coverage analytics solution that will take advantage of machine learning in a collaborative environment. And finally, we provide a complete functional safety solution that analyzes ARM designs for safety, synthesizes and inserts safety mechanisms, and then using concurrent fault simulation, we can prove that ARM designs can recover safely if a fault does occur in the field, or we can integrate into the Tessin ATPG environment for manufacturing defect analysis for fault simulation in that environment as well.
Okay, great. Next up is Jean-Marie Brunet.
Hello, hi, my name is Jean-Marie Brunet. I'm Senior Director of Product Management for Emulation and Prototyping at Siemens EDA. So on the follow-up from what Mark just mentioned, I'll elaborate a little bit more on how we collaborate with ARM and how do ARM partners benefit from this. So it's really in three areas. The first one is having early access to RTL of ARM core and being able to tweak as much as possible our software and our hardware to ensure smooth and optimized compilation of all their cores on all of our hardware solution is very important. And with that, we're able to get the best performance possible on their core running on our hardware. The end result is really good quality and great performance for the ARM partners. The second area is more on the virtual domain. There's a lot of work going on right now after some announcement on hybrid and virtual platform. But we've been doing this for many years with ARM, having access to the AFM, ARM fast model. We're able to very early on customize our Veloce Icon platform by providing a software stack all the way to a Linux and Android, and I'm sure Scott will talk more about that software as well, and providing a hardware configurable platform with ARM cores, deliver part of the Veloce Icon. And it's enabling ARM customers that do SoC integration using ARM cores to shift left their verification of the complete SoC. And the third aspect is more respect to the question from Mike on what is current and what is in the future. And this domain is more on the system of system. We've launched many years ago a program called PAVE 360, and we are using a lot of ARM technology in PAVE 360, particularly in the compute aspect. In this domain, you have a lot of sensor, a lot of computation, and a lot of actuators. In the compute, in the very advanced compute, ARM is a key partner. We are able to do high fidelity modeling of very complex system and SoC behavior. We can switch from virtual to RTL, virtual to hybrid to RTL, sorry. And we can do that not only for cars, with which PAVE 360 was targeted at the beginning, but for any type of planes or anything like flying taxi, many more opportunities and different domain, vertical market domain that we can approach with PAVE 360. That's it.
Okay. Next up, Scott Morrison.
Okay, thanks, Mike. Hello, everybody. My name is Scott Morrison. I'm the General Manager of the Embedded Solutions Group in DISW, a portion of Siemens. My topic is a bit different than the previous two topics, which were focused primarily on silicon and design and test and verification of that. But as Jean-Marie pointed out, it's really a combination of the hardware and the software that kind of enables these really, highly functional, compelling devices we're all used to these days. And our group is focused on supplying the embedded software, specifically for those smart connected devices. The particular areas of focus for our group include embedded operating systems, so leading embedded Linux-based operating systems and a real-time operating system as well, for maybe higher performance or more deeply embedded applications. We also fairly uniquely can mix and match these things together and have software architectures for the very complex, heterogeneous embedded SoCs that are really enabled in kind of a strength of the ARM offering and the processors that they enable. One could even say that ARM kind of created that market. And we extend beyond those base offerings with both safety and security offerings. In the case of safety, then we safety certify some of our runtime software, in particular the real-time operating system and also the multi-core framework for those heterogeneous processors I mentioned. And then for security, I mean, that's a long topic in itself, but we do everything from secure boot up to almost every other aspect of security to keep the processor safe, and all the runtime software, of course, and all the communications with the embedded devices. So beyond the collaboration with ARM and the ARM licensees to have this broad embedded software portfolio available on these complex SoCs, we also work with ARM directly on kind of tools enablement. So they have the development suite, the development studio tool suite. We support that with our runtimes because obviously it's the best in class, including the probes that they offer. And for our real-time operating system, I mentioned before, it's safety certified, and we use the ARM functional safety certified compiler as the compiler of choice for our runtime. And we also have some special integration to leverage the ARM GPUs for our embedded machine learning solution. So for the kind of the final topic that Mike was talking about, kind of looking forward, now that we're part of this much even broader portfolio of products within DISW, things that we're working on now include developing and actually now offering an end-to-end cloud solution. So all the way from these secure, smart, embedded processors or devices, all the way up through the MindSphere IoT cloud solution. We're also working with Mendex, so people can develop very rich applications on mobile devices like smartphones and tablets, and then they can interact directly and securely with embedded processors or embedded devices. And then we're also working with some of the other groups within DISW on application lifecycle management of our software within the greater context of how customers are managing the software for the very complex devices that they're developing. So back to you, Mike.
Okay, yeah. Just to let you know, in case you joined us a bit late, if you have a question for us, please feel free. You should be able to see a box at the bottom of your screen that basically allows you to ask questions. We don't have any questions so far from the attendees, so I prepared a couple as backup. And maybe I'll just ask just a general question. How are your technologies addressing functional safety? And yeah, we can kind of, if you want to take that, Scott, you maybe.
Yeah, no, I could start with that one for sure. I think the other presenters probably have something to say on that as well. But since I already broached the subject, so to speak, so sure. we do offer safety certified components because functional safety is, of course, kind of a system level or a device level problem or challenge. And so our customers have to look at the entire device. And of course, whatever third-party certifiers or regulatory agencies that they're working with look at the entire device. So what we do within our group is just look at the embedded software. And our goal is to basically offload as much of the burden as possible from our customers so that a significant portion of the embedded software that goes in the device can be licensed from us. And if it's, for instance, our real-time operating system and our multi-core framework, that actually comes pre-certified. And so certain industries and certain safety certification standards allow what are called software elements out of context to be pre-certified. And we supply those to the customers so they can basically integrate that as part of the safety case for the entire device. Just to get into a little bit more detail, we're seeing a trend within the market right now, an interest of using Linux in at least medical safety certified devices. And so we had some lead customers we worked with through the process with them on a services basis. And just recently this summer, what we did is we created what's called a quality package for Linux, specifically targeted for medical, although it could be used in other industries. And then what that does is allows them to utilize Linux and addresses Linux as what's called a software element of unknown provenance. And so that's a specific term in the 61508 medical safety certification. And we've had one customer be successful, and we're working with several other customers of using Linux. And that's something that a lot of people a few years ago probably would have said was not really feasible to use Linux, but we're working with customers on that today. So really kind of extending the functional safety offering in that direction.
Okay, great. Mark?
Yeah, sure. Yeah. I can do that. The functional safety economics are quite challenging. I saw a keynote a year or so ago where an executive from one of the large automakers described that just the same way that as your flat panel TV was evolved to be a smart TV, that there was very little incremental margin that could be attributed to the additional functionality, and that the same is true for functional safety in chip design. So there's extreme pricing pressure, and that puts the challenge to us to be as efficient as we possibly can. We acquired a technology a couple of years ago called Austemper that we're integrating into both our design verification technology as well as our DFT technology, and it can start on the front end by understanding the design and looking at the ASIL safety levels, providing analysis for you, and then synthesize and insert things like voting, triple level redundancy, ECC, safety mechanism controllers and such, and then ultimately help bring you into the environment, which for some of us is kind of like a blast to the past in fault simulation. But it's not traditional fault simulation where you're just faulting stuck at highs and lows, but you're actually looking for the behavior of faults and then trying to understand how do they recover safely. And as you can imagine, simulation itself has become such a CPU intensive challenge. Now look at moving into the fault simulation environment where you're simulating multiple instances and faults, multiple designs, and distributing that across broad networks and such. And so that can be a big challenge. But I think that Jean-Marie will probably have something to say about how to achieve performance in this environment, moving into the hardware-assisted verification environment, which is also an area of heavy investment for us.
Okay,
that's correct, Mark. This is an area of collaboration actually with DVT. Really, the way we see this is with functional safety, as Scott mentioned and Mark mentioned. A lot of customers are very concerned with this. So as a result, they're actually running even more verification cycle. And certain environments are very tailored to accelerate quite well on hardware platform, and others less. Fault, for example, DFT, are very, very good prime target to accelerate on a hardware assisted verification type of environment like we provide. So as Mark mentioned, there is a real good continuity on what is done on the simulation environment to accelerate the simulation performance on a dedicated hardware like an emulator, Veloce, or prototyping, Veloce Primo or Veloce Pro FPGA. Those are prime target. And on functional safety, we see a lot of concern of linking DFT and fault. So we created for that a DFT app and a fault app. And we are dealing precisely with conversion of format and acceleration of the verification of the objective target, which is to run a lot of simulation, and we just accelerate tremendously the performance to go faster to a result on how is the test bench and the design performing versus the functional safety target of the design.
Okay, great. Okay, if anyone has any has a last question, we could put it in their box below the screen real quickly, and that would be great. Let's see. Well, it looks like we don't have any other questions. So maybe I'll just ask you if you could just kind of quickly talk about what each of your groups are doing in terms of AI and ML. I know it's probably longer, and we might have to cut you off at some point because we're getting down to it. But we have 5 minutes. Jam, since you're up, Jean-Marie, since you're up, why don't you go? Yeah.
Sure. So this is very interesting because AI ML, I think one of our competitors made a lot of noise recently about AI ML, but I think they talk a lot about in the space of design implementation or design realization. In our space here, it's more about how to apply AI and ML techniques to design verification. And that's a different domain by itself. This is nothing really new for us. In the verification space, there is really two main things. There is an explosion of data when we run a 10 billion gates or 15 billion gates design on an emulator, and you have access to full visibility of what is happening. You have a huge amount of data that is available to you. So creating an engine that is able to extract that data and train out of this data the setup on how to run that hardware is basically one vector that we have been working on for a while now. And we're using those techniques to basically over time train and improve on how to use more efficiently a very complex high performance compute engine like an emulator and drive the setup of our script and constraint so that compilation is more effective, runtime is more effective. And we've been doing this for a long time in the design verification space. Some technology will be announced, some technology are part of how we optimize our compile flow, for example. And so this is very vibrant, but this is not something that is new for us in the design verification space. We have been doing this for a while.
Okay. I made a bit of an error because it looks like I needed to refresh my screen. There were questions that did come in. So we have one you mentioned pre-certified, this is like probably for Scott, you mentioned pre-certified software to your customer in regards to some functional safety standards. Have you considered to provide a pre-certified software regarding to security?
Yes, yeah, that's a really good question, actually, because I think security, I mean, it's becoming paramount, obviously, in many devices in terms of the design and the maintenance of those devices. We don't have any pre-security certified software right now. We are considering it. In fact, we're more than considering it. We're working on it. We started looking at some standards from the various markets. I think we're in the process of down selecting to one or two, and we're aligning those. What you really do is you end up looking at, your development processes and your coding standards and things like that, and the static analysis that you're doing on your software, which used to be always for bugs and then for safety, and now it's emerged for security as well, and there's very good tools for that. So we are in the process of doing that. I would also say the other thing, which is really kind of a key offering for us, I would consider it a best-in-class offering, because we get to leverage the whole power of Siemens, is monitoring vulnerabilities. So we have a very, very comprehensive offering to customers where they can sign up, and we will give them patches beyond just kind of the standard kind of national list that people can sign up for. But Siemens is very, very proactive in this area and monitoring threats that I think very few other people monitor. And we take all of that information and create security patches for our customers and make those available to them.
Oh, okay, great.
Mike, I'll mention just real quickly as well on the security front.
Yeah,
from a
sure.
hardware applications perspective, our formal verification technology is really optimally set up for this, using formal techniques to be able to exhaustively look at a design and analyze it statically, excuse me, to be able to find any unintended or unwanted paths to memory, to registers, or to other parts of the design. So it's from both the hardware and software perspective, we've got heavy investments going on.
Okay, great. Okay, we're getting close to time, but we have 3 minutes to go, and we have a question from Ann Muchler. How does the interplay between customers, foundries, and partners look today in leading edge applications?
You want me to?
Kind of a general question.
I'll say one word. So this is a very interesting question, because when we made the announcement of our new hardware platform, we actually emphasized this. Software today is really what drives if a semiconductor application will work or not. It's no longer a functional specification and so on. This is really a software workload. All of our customers on leading edge type of devices, they are running live software workload. And how the behavior of that software workload is matching the behavior of their hardware is well dictated if the semiconductor will basically pass the test or not. So we see that really that shift, the heavy burden on running very complex, long cycle, real software workload is what I think is changing on leading edge application.
Okay, great. Okay, it looks like we're pretty much to the end of the session. Thank you. I think we got a lot packed into that 25 minutes. And I want to thank all the attendees for joining us. And I want to thank the panelists for also joining us. And thanks, ARM, for facilitating everything. This was fun. Yep. So I appreciate everyone joining us. Take care.
Thanks, everybody.
Okay. Thank you.
Stay safe.
Yeah.
Stay safe.